Hi, everyone, and welcome to Discovery Presents Chats with Changemakers. I'm your host, Tiffany, and I'm a ninth grader in Texas. I participated in Discovery's Future City competition when I was in middle school. Every Friday, we will welcome a different guest from the engineering community. Today, our special guest is David, an engineer at TE Connectivity. David, welcome.
Hi, welcome to everyone.
So, David, tell me a little bit about your career.
Sure. So I graduated college in 2018 from Howard University with a mechanical engineering degree. And then I went on to start working at TE Connectivity. I'm in a rotational program, which means that I get to experience a lot of different jobs very quickly so I can kind of understand what I like to do and then go into a full-time role.
Cool. So, what type of rotations do you do?
A ton of different ones. So specifically in the transportation solutions sector. So I work with a lot of different automotive companies for like everyday cars that you drive. I also work with industrial automotive. So things like Caterpillar, John Deere, some type of farming equipment, things like that. And also larger trucks like 18 wheelers and things of that nature.
So, what exactly do you work on for those specific things?
Sure. So TE Connectivity, specifically for the job that I work for, we create different electrical components and things that are inside the vehicle to make them run. So things like your backup camera or sometimes helping assist with steering, all different types of electrical components that go inside to help you drive and make your car function.
Okay, cool. So, what rotation do you like the best? Do you have a favorite one?
Yeah, so one of my favorite ones was with the 3D printing group. In the industry, they call it additive manufacturing. Usually, you use subtractive manufacturing to take a big block of steel or some type of material and you chip away at it until it looks like what you need it to look like. With additive manufacturing, you start with a blank space and then you can basically 3D print whatever shape that you need to have. So it's the opposite of what people use now, but it's a lot quicker and faster and it's really cool. So it's something that's coming up that we hope to use more in the industry.
Wow, so what are those models like used for?
A ton of different things. So right now, because it's still like in the early stages and prototyping, I actually have an example here. So we have a couple of different connectors that we make, and then we can have these different samples that we use for 3D printing. So I don't know if you guys can see these, but these are just different samples of different 3D printing.
Wow.
Yeah, they're pretty cool. So we can use this kind of just to figure out, what type of material we want to use, or to show them off, just to show the different, I guess, attributes of different materials that you can use. So we start those models and they can be used for different connectors, just like for plugs. They can be used for housing. So if you want to sit something on it, you can make that 3D printed. They can also be used for cabling. There's a ton of different uses for 3D printing. So right now, when we're still doing a lot of research, we don't exactly know what the niche will be for it. But for right now, it can be used for a lot of different things. Anything that you can come up with, you can basically design and 3D model.
So, how long does it take to make just one of those?
Um, well, I would say that for the design, for you to actually come up with it, it kind of takes as long as you need it to. For things that are simple, maybe like 5 to 30 minutes. More complex designs can take about, maybe a whole entire workday, maybe 8 hours. Now, if you have an assembly that takes a lot of small parts and puts them together, then that'll take maybe, days or months. So that's just the design aspect of it. Now, after you design it, you actually have to either model it with additive manufacturing or subtractive manufacturing. Now, additive manufacturing takes a little bit longer because it's a little bit newer and the system is a tiny bit slower. So when you're designing something with that, depending on how large or complex it is, the print could take maybe 5 to 6 hours. If you have something small like these, like an individual one of these will take no longer than like 5 or 6 minutes to make. And then with injection molding is the other type of kind of manufacturing process, which is also subtractive manufacturing. Those could take 1 second. As soon as it snaps together, it shoves the plastic in and it pops out. So you can do that all
Wow,
day, in like 2 or 3 seconds, and it'll create parts over and over and over again.
that's awesome. So, how did you learn how to do that?
It's definitely kind of like on the job learning. So when you're in school and things like that, they'll teach you the basics and the fundamentals and the theory behind engineering. But a lot of times your experience is really going to come from the job that you have. So you'll learn about manufacturing processes and the right and wrong way to do things kind of on the job. And it's nothing to be scared of. That's kind of how it always happens. When you come in, they don't expect you to know everything. You don't have to be a super genius, but they'll definitely teach you the steps in the process. So like in the first maybe 4 or 5 months of your job, you'll just go through training to learn how to do all those things.
Well, it sounds like you've gotten to work on some pretty cool projects. What do you think, if you had to pick one, would be your favorite project of all time?
Sure. So one of my favorite projects of all time was 3D printing validation. So what that means is, like I just said, this is something like a new technology. It's kind of on the forefront. So we have to validate different materials so before we can use them to make sure they have the right properties, make sure that they can stand up to the temperatures and vibration and all those things that we're going to use it for. So one of my projects was I had to come up with different 3D designs and then go to the lab and actually test them to see if they could hold up to the right temperature and things like that. And I did that on two things. So I did it on plastics like polymers and things like that, kind of like the regular 3D printing that you see. And I also did it on metals. So we also had to test different types of metals and see if you could actually 3D print metal and then what it would look like on the other side. So I kind of went through, I got to do some design, and I also got to do some actual validation testing back in the lab. So I got my hands dirty a little bit. So that was pretty cool.
Wow, that's awesome. So for kids watching that may want to become engineers, what do you think they should focus on in school? Are there any programs or specific classes that they think that they should focus on?
Yeah, definitely. So I would definitely take a closer, a deeper look into all your basic maths. So like, your geometries, your algebras, when you get a little bit older, trigonometry, those will really set your foundation to be a great engineer. Those are probably the building blocks of what you need. So you may not use them every day in your job, but having the knowledge of what they mean and the processes and theories behind them will make you so much better at your job, and even going through school and college and things like that, because it'll make learning the higher level maths that much easier if you have a very, very strong foundation.
Okay, so here's a cool audience question. So an audience member heard that a company is going to 3D print a whole rocket. What do you think of that?
I think that's great. I think it can definitely be done. One of the things that we did at my company to kind of show off additive manufacturing possibilities, we built an entire 3D printed motorcycle that could actually be driven and things
Really?
like that. Yeah, yeah. So we took each part, and we have industrial 3D printers. So a lot of times you'll see at home or hobbyist printers that are kind of small. They look like your printer at home that you would use for regular paper, but we have ones that are at our facilities that are like 7 feet tall and maybe like 4 feet
Oh my
wide.
God.
Yeah, and they can print very large parts. So we printed all of them out, and then we put an electric motor in there, and was able to drive it around. There's a guy named Bob Zubricki. He's one of the founders of 3D printing. He's been around in 3D printing for a long time, and he's taught me a lot, and he's taught a lot of other engineers about 3D printing. So it's really cool to learn about that experience and kind of get some feedback on how 3D printing is going to move in the future. So I think that building a rocket will definitely be a challenge, because you have so many forces you have to get through the atmosphere, and it's a lot of speed, and all of that will create friction. But I think that if take the time and do some iterative processes, so you have one, it may not work, print it again. That's the beauty of 3D printing, is because it doesn't take a lot of time or a lot of money to make it over again. So if that first rocket doesn't work, it's easy to scrap it and then go on to the next one. And so I think in the future, we'll definitely be able to use 3D printed rockets.
That's awesome. So we have another audience question. So they heard that you mentioned metal. How exactly do you 3D print metal?
Sure. So there's tons of different ways to 3D print in general, right? And one of the old is called FDM, and that's basically an extrusion process. So what you have is you have a thin piece of plastic, and it gets heated up through a nozzle, and as it's being extruded through the nozzle, it cools, and you can basically cool it in the shape that you need it to be. And that's the same thing that happens with metal printing. It's a little bit hotter, a little bit more messy, but they take a very fine amount of metal, a very thin piece, and they can superheat it. It's almost like welding. You could think of welding, but instead of welding on a flat surface, you're welding in a 3D printed space. So you're kind of welding on top of a weld, on top of a weld, like that. So that's one way. Another way is to take a fine kind of like sand or grain, and then you can superheat it with a laser, and the laser will take all the sand, well, it's metal, but it looks kind of like a sand, and it'll superheat that exact area that you need, and it'll start to form a shape. So you can use a laser from a super high powered laser that'll melt the metal together into clumps, and then you can essentially draw what you need to make in that.
That's awesome.
Yeah, it's
How
pretty cool.
long, or like when was that developed? Is that pretty recent
Yeah.
technology?
So 3D metal printing is pretty recent. I would say in the last 10 to 15 years or something like that they've had, metal printing. And as it's gotten better, it's become more commercialized. So unfortunately, you can't buy any metal printers for your home, like you can buy 3D printers for plastic. But metal
Yeah.
printers are becoming a lot more available, and you'll be able to use it, for those rockets and things like that. They have 3D printers that can print homes, and all those things. So the scales that we use for 3D printing are endless.
That's so cool. I didn't know that you could 3D print like really, really big objects.
Yep, it all depends on what size you have. So the ones that you can use at home, you can maybe print like phone cases, or maybe a wallet holder or something for your keys. And then if you get to the really big ones, maybe they don't have an entire enclosure, but what you'll see is kind of like maybe like a crane type structure that will hold the nozzle, and it'll be a really big nozzle now. So you could imagine like a lead pencil, kind of like how the lead pencil comes out, and that very small hole that the lead comes out of. Now imagine like a water hose or a water fountain, and that has that much more available space to kind of print what you need. So it gets very large, and it takes a lot more time when you're doing it on those big scales, but it can definitely still be done.
That's awesome. So I want to shift to a little bit more of career-based questions.
Okay.
So when did you decide that engineering, or even more specifically, mechanical engineering, was what you wanted to do with your career?
Sure. So when I was younger, I was always like a tinkerer. Like I used to play with Legos all the time, Bionicles, any type of thing that you could put together was pretty cool to me. And as I got older, I never really wanted to get rid of that. So I knew that I wanted to do something in science, and I didn't know really what it would be. But my uncle was actually an engineer as well. So I kind of took some inspiration from that, wanted to be an engineer. And then reason why I chose specifically mechanical is because I love cars. Cars are one of my passions. I love fast cars, like that you can customize them, and that they come in so many different shapes and sizes. And it's really like, you can become one with the machine. And so I was trying to figure out what type of engineering would get me closest possible to vehicles. And that was mechanical engineering. So that was kind of my thought process of becoming a mechanical engineer.
Okay, very cool. So now that you actually are an engineer, what would you say is your favorite thing about your career?
One of my favorite aspects of my career or my job is that um, you you never know what you're going to get into for a day. It's not the basic or typical desk job that you have. There's a lot of, you do have a desk, and there are meetings and things like that, but there's a different type of feel to it, right? You're always solving problems. I get to use 3D modeling software on my computer. So I'm actually, designing and drawing things at work. I get to go to the lab sometimes and, put things in the oven and melt it and see if it's going to withstand the temperature, or you could put it in a pressure chamber. All these different types of functions that you can use and kind of, have hands-on experience, but then also go back to your desk and, you can make it formal. So I like kind of having both sides of that.
Right. So I have another quick question about 3D printers.
Mhm.
How do you like take an idea and have the 3D printer actually like make something out of it? Like, how do you get the program to the printer?
Right. So it first starts with the design. So I have my phone here. Like if you wanted to design an iPhone, right, you would have to draw this in a 3D modeling software. I think the most popular one is called SolidWorks, or something like that. You can use NX or Creo. There's tons of different modeling softwares. So that'll be the 3D design. It's not going to have any, you can't touch it or anything like that, but it's going to be on the computer. From there, it has to go to a slicing software. And so what the slicing software does, it'll take your design and it'll chop it up into different small layers. And it'll kind of analyze them layer by layer. And these layers are very small. So it'll be like 1 millimeter or even half of a millimeter or something like that. And it'll basically make this into different layers that the 3D printer could print. So then you can either plug it up with like an Ethernet cord or Wi-Fi or something like that, or either take it from a USB and plug it into the actual 3D printer. And the 3D printer will convert those very small layers that are like a millimeter a piece, and it'll take the material properties, and it'll take the color, and it'll take what temperature it needs to be and how much material it needs to deposit, and then it'll do it layer by layer, one by one. So what the computer sees is just each layer, and then at the finished product, it'll actually come out in the shape that you need it to be. So that's kind of how.
Yeah, that's very interesting. So we have another audience question. What has been the most challenging project that you have done?
The most challenging project. I think one of the most challenging in terms of 3D printing are a product that I was doing that was a connector, and it had a lot of internal components. So if you look at a connector, sometimes you take a plug at your house, or like your connector for your phone charger, right? It has the plug that goes into the wall, and it has like the adapter. That's pretty simple. It's kind of like just a square. It has a lot going on, but you can't see anything, right? Now the connector that I was using had like a lot of internal kind of, what they call them, overhangs, so things that are pointing out of the inside. And when you're 3D printing, it makes it hard because a 3D printer has to print on top of something. It can't just print in thin air and just something that's hanging. So if you do that, the material will go and just kind of fall off. So you have to orient it in ways where it's not really hanging by itself, or you can use supports. So being able to trying to figure out which way not only to design it, but then to orient it in the right direction to make sure that there's no overhangs and that everything is printing correctly and one layer by layer was probably one of my biggest challenges.
Okay, awesome. So it's important to try new things, even if they're hard. Is there any part of your career that maybe hasn't gone as well, and you failed, but you learned from that experience?
Yeah. So I guess there's always learning curves, right? So even though it may not be a failure, but it'll take you some time. It may not be what you're comfortable with, or it may not be what you're used to, but that doesn't mean you should stop trying. So, at the beginning, designing these really complex things was pretty hard for me, just because I've never done it before. Sometimes when you're learning in school, they give you projects that will teach you the basics. But when you're working for a company, they'll give you problems that have never been solved before. So me learning the 3D printing software that we use at my job, or the 3D modeling software that we use at my job, was super difficult. It was very challenging because I didn't know where any of the buttons were. I didn't know, what the proper procedure was to design. So it was really challenging for me to do that, but I stuck with it. It took me, a lot of failures. All my designs didn't come out right, or they didn't work, or they weren't printable. They just kind of came out with like a blob of nothing. It was just kind of like stringy material like that. But over time, as I took those failures and learned from them, and then took each bit that did work from those failed projects, I compiled them all up until I got something that worked. So you just got to keep trying at it, and you take little nuggets of success from those failures, and it'll turn into your overall success.
Okay, very awesome. So in what ways do you think your job encourages you to be a change maker?
I think what encourages me to be a change maker is always asking why. That's one of the biggest or most important questions that you can ask. When you ask why, you can that's the beginning of change, right? So all the time, in my job or in my life in general, I like to make sure I'm asking why, and is this the right thing that we should be doing, or is there a way that we can do it better? If you don't question that, if you don't challenge it a little bit, you'll never know how to make things more better, or improve it, or innovate, or get to that next step that no one has ever done before. So I think, being able to ask the question why is what makes my job, or makes me myself, a change maker.
Right. So what do you see yourself personally working on 10 years from now?
That'll be interesting. It all depends on what's a hot topic at that point. I think that there'll be a lot more 3D printing instead of injection molding. But I think that they'll also be more complex. So instead of designing single parts for whatever we're making, whether it be for cars or for houses or for electronics like Xboxes and video games and things like that, instead of making just the internals, I think that we'll be 3D printing the whole thing at one time. So if you can imagine an Xbox controller, you can print the face and you can print the back, and then you have to print all the parts one by one and then assemble them. But I think at some point we'll get to the point where we can put all the restraints in, and it'll print the entire 3D controller in one go, and you can take it off the shelf and just go ahead and start playing with it.
So that must be a lot faster then, right?
Yeah, that'll be a lot faster because you don't have to ship the parts somewhere else to get them assembled, or you have to make them in one place. Everything will be in-house from one computer, and you can take that part once it's done and then ship it right out to whoever needs it.
Okay. So I want to talk a little bit more about you.
Okay.
What do you like to do in your spare time?
So that's a great question. One of the things I like to do is play Xbox in my spare time. So I'm still a huge gamer, even though I'm getting a little bit older. I still love to play video games and things like that. So Fortnite and Call of Duty, all those things I still love to do.
Awesome. So I understand that you're very active in NSBE. Can
hmm
you tell me a little bit more about that?
Sure. So NSBE is National Society of Black Engineers, and that's one of the things that really got me prepared for my job and for just school in general. It really gives you a sense of working as an engineer. So a lot of times you'll learn, the front end of things and the science behind it. But NSBE really cultivated my professional skills. It allowed me to be able to talk about engineering. It allowed me to show how to dress professionally, how to interact in those environments. And it was a really big achievement for me to not only be a member of NSBE, but then to become a leader of NSBE as well. It gave me leadership skills. It showed me how to plan events. It grew my network. So I met a lot of people during my time in NSBE. And they also have NSBE Junior. So NSBE is for colleges, but they have NSBE Junior chapters at a lot of high schools and middle schools as well. So I would definitely encourage individuals to seek out and see if they have NSBE organizations or NSBE chapters in your area, and it'll do wonders for your STEM career and just being a better person overall.
So you mentioned that you had important leadership positions in the NSBE program. What
Mm-hmm.
qualities do you think makes a good leader?
Listening and understanding, I think, is one of the biggest things that you can do as a leader, and also leading by example. There's a lot of different types of leadership, but I think being able to listen to the people that you're leading and to be able to show them what you mean and what characteristics you want to have in that leadership role. So when you're listening to people, you want to make sure you hear what they're saying and try to put yourself in their shoes to understand what needs they have and what they
Right.
want to get from the organization. And that's what I tried to do. And also being that example. So you never want to tell someone to do something that you're not doing yourself, or to give them advice that you're not taking. So you also want to, whatever you're saying or whatever you're projecting into the world, you want to live by that same example that you're showing. So, kind of keeping those values close to your heart and projecting them throughout your everyday work, when you're talking with your friends, even with your parents or anything like that. Definitely want to keep those same values that you're leading with in your everyday life as well.
Right. Okay, I have one last question for you. It's a kind of a fun and random question.
Okay, sure.
If you had a time machine, what time period would you choose to visit and why?
Okay. So I think that if I could go anywhere and anytime, I would like to go to ancient Egypt. I guess being a STEM major, that's really exciting to me to be able to do those engineering feats with no modern technology. Being able to kind of think at that high level so long ago when, kind of the world was still young, and society was still young, and to be able to create these things that are still standing today. I think their culture overall is very interesting to me. So I would definitely want to travel to ancient Egypt to see it in its prime.
Right. Okay, well, David, thank you so much for joining us today. And I hope that you all will join us again next Friday, where we'll meet Molly, a cyber engineer at Raytheon. She tracks down hackers around the world. Until then, I hope everyone has a great week.
Thanks, guys.